Hi, everybody. This is Dr. Dado presenting second discrete time modeling and Python. This will be the concluding video on discrete time modeling. This is the second of my two videos on discrete time modeling. In this presentation, Python codes are used to analyze a three-dimensional system. As usual, I've assumed that my audience is aware of the system. Even if you are not aware of the system, at least the system will come from you as a user. So you must have obtained the system from one means or the other. The system I'm using here is hypothetical. It looks like a Mobius wand that has been wrapped up. But if you are the owner of the system as a researcher, then you know where you get the system from, and you have information about the system. All Python will do for you is to help you to visualize the system, give you what it looks like. Before now, some other software that are a little bit difficult to use were often used for this, but it's a little bit simplified with Python, and that's why we're talking about it. So the codes I've used are reusable because of the OOP format. The requirement is similar to the requirement we had in the first discrete time model video. If you haven't seen that, please go get that. It's my immediate past video. Now, the discrete time modeling, this time it is to illustrate how Python will handle 3D systems, three-dimensional systems. In the last video, we saw how it will handle a two-dimensional system, just X, Y. In case of prey predator, X for prey, Y for predator. Here, there are three axes of reference, X, Y, Z. This is the natural axis of reference. In real situations, you have X component, Y component, and the Z component. So how would Python attend to this? The scales are uniformly given. They are just between -2 and +2 in the increment of 1. So that's the system. Okay. The codes. You have to import this from PyLab import star. From that import the three-dimensional axis. Well, definition initialize X naught, Y naught, Z naught. When this is given, Python will look for this. If it can't find it, it will flag an error. Initialize, this command tells it go and take the least value for X naught, Y naught, and Z naught. Keep them in these three locations. Box them up in the sense that the three are related to each other. Then observe. When it's observing, it's looking for this. Once it gets this, it will carry out the evaluation. Then go back to wrap it up. Then goes to pick up the second set of values. It continues doing this loop until when it is done. When it is done, now it presents the diagram to the user in the most acceptable, in the most preferable form. Okay. The codes we've just seen, this is the diagram it has produced, the visualization. Okay, the visualization shows in slide 5 is the required three-dimensional diagram of the system. Under investigation, Python always presents acceptable diagrams upon request from the user. Note, there are differences between the given scales of x and z, even although that of y is kept intact. Well, and the scales in the diagram, y has used acceptable, scales here on x and z. But by the time you see the output, you'll be okay. You won't kick it off because at most times the output will encompass the given scales. Python will often use convenient scales that are larger, often larger than the given one, so that it will encompass it. Continuity. This is the farthest I intend to go, but before I go, I intend to also show you what the Jupyter notebook looks like. This is the code we supplied. Like I explained, it's usually colorful, and it continues, and that is its product, the diagram. Well, that's the farthest I intend to go in the second slide. The second video on discrete time and Python. It depends on what you want to do. Engineers will find this captivating because it borders on much of their work, more than it does to us statisticians even. But these are it's just the system, it's just that the system are convertible. There are other presentations for the system. There are differential equation format for the system, the continuous systems. But they are also convertible to discrete time, and that's why we are looking at it. So thanks for listening. See you next time. When I come up with another system.